Hi, this is Algebra 1, Lesson 1-5, Solving Inequalities in One Variable. In this lesson, we'll be able to solve and graph inequalities. Let's start with model and discuss. Skylar competes in a high jump event at her school. She hopes to tie or break some records at the next meet. So if you look at the picture, her personal best is 1.48 meters. District record is 1.57 meter, and state record is 1.75 meters. Part A. Write and solve an equation to find x, the number of meters Skylar must add to her personal best to tie this district record. So we're looking at the district record. And we're writing an equations to start with. Okay? So whatever her personal best is right now, 1.48, if you add a variable, x, that she needs to add, that will make her tie with the district record 1.57. Then this is your equation that you need. B. Rewrite your equation as an inequality to represent the situation where Skylar breaks the district record. So instead of tying the district record, she wants to break the district record. What is the value of x in the inequality related to the value of x in the equation? So let's first set up an inequality instead of equality. So the expression on the left of the equation shows her record that she's gonna get. So that needs to be greater than the district record 1.57 in order for her to break the record. So 1.48 plus x needs to be greater than 1.57. How is the value of x in the inequality related to the value of x in the equation? Are they going to be different? Yeah, because if you add the exact amount to become 1.57, that's going to be less than the amount that needs to be greater than 1.57. So x in the inequality is any value greater than the value of x in the equation. So you know that this x will be greater than this x. Part C. How many meters does Skylar need to add to her personal best to break the state record? Now we're looking at state record, 1.75 meter. And she wants to know how to break it. It means you're going to use the inequality instead of equality. So we can say greater than 0.27 meters after we solve for it. So 1.48 plus 8 needs to be greater than 1.75, and we solve for 8, and we solve for x. 1.75 minus 1.48 should be 0.27. Okay? So this lesson's essential question is, how are the solutions of an inequality different from the solution of an equation? So keep comparing the differences between equations and inequalities. Let's start with example 1, solve inequalities. Let's solve the inequality -4, parentheses 3x minus 1 plus 6x greater than or equal to 16 and graph the solution. You would apply the properties of inequalities to solve for x, which is very similar to the equations. First, you're going to start with solving for the parentheses. So you're going to distribute -4 with 3x and -1 to get -12x plus 4 plus 6x greater than or equal to 16. And then you subtract 4 on both sides in order to get rid of 4 here. And you get like terms here, 16 minus 4. And you can add the like terms. -12x plus 6x will be -6x. And 12 is just 16 minus 4 is just 12. And then when this is the only rule that is different from equation. For inequality, when you multiply or divide by a negative number, then you need to switch the inequality sign. Because when you multiply or divide negative, what is your product or your quotient? It changes your sign. So if it was your positive number, if you multiply a negative number with a positive number, it becomes a negative, right? If it was negative number, if you multiply a negative by a negative, it becomes positive. So when you multiply or divide by a negative number, then the signs of the original value switches. So if you think about the number line, positive side and the negative side will switch. So your inequality has to also flip over whenever you multiply or divide by a negative number. Now, when you're adding or subtracting negative number, does it matter? No. Only when you're multiplying and dividing is when you have to switch the signs. Okay? So then your answer is x less than equal to negative 2. It is not greater than equal to. Your answer has to be less than equal to. Graphing the solution, you're going to find negative 2 on the number line. Fill in the circle because it's less than equal to. If it was less than, if x was less than negative 2, then you do not color the circle. And then you go left. Okay? But if it's less than equal to negative 2, you have to fill in the circle on negative 2 to indicate that your negative 2 is included in your answer. It's also equal to negative 2. Okay? And go left to indicate it's less than. So now it's your turn. Try number 1, A and B. Solve each inequality and graph the solution. Pause the video and come back when you're ready for answer. Okay, are you ready? So solving this step by step, you solve the parentheses by using distributive property first. So negative 3 times 2x would be negative 6x. And then negative 3 times 2 is negative 6. And that's less than 10. Okay. And then you add 6 on both sides, and you get 16. And then your x, your negative 6x divided by negative 6. Now, when you're dividing it, you have to flip the sign. So now that's greater than 16 divided by negative 6. So you have x is greater than 16 over negative 6, which could be simplified as negative 8 over 3. Okay? So on the number line, you're going to graph the solution. Negative 8 over 3 is approximately negative 2.6. So you're going to have to graph between negative 2 and 3. It's going to be approximately here, and your circle is an empty circle. And x is greater than that, so you need to go right. So that is your solution in the graph. Part B, 2 times parentheses 4 minus 2x. You use the distributive property and get 8. 8 minus 2 times 2x, 4x is greater than 1. So then you have 4x greater than 1 minus 8 when you subtract 8 on both sides. And then you have negative 4x greater than negative 7. And you're going to have to divide by negative 4, which means you're going to change the sign. So your x is less than negative 7 over negative 4, which will be simplified to 7 over 4. And now graph the solution as well. 7 over 4 is approximately 1.75, is exactly 1.75. So on your number line, you're going to have to graph 1, 2, 3. 1.75 is, if that's half, and that's fourth, then your 7.5 is here. And it's a empty circle. And x is less than that, so you go left. Okay? Alright, that's how you solve an inequality and graph the solution of an inequality. Let's move on to example 2 on the next page. Solve an inequality with variables on both sides. Solve 3.5x plus 19 greater than or equal to 1.5x minus 7. Then graph the solution. So you're going to do the same thing. You're going to combine like terms and try to subtract and add on both sides. So you can subtract 1.5x on both sides, and you can subtract negative 19 on both sides so that you get 3.5x minus 1.5x. You can subtract that, and then that's 0, and that's 0 too. So you get negative 7 minus 19, which makes 2x greater than or equal to negative 26, and x is greater than or equal to negative 13. You don't have to flip the sign anywhere because you're just subtracting. And you're graphing the solution. If x is greater than or equal to, you have to shade your circle on negative 13, and then you go right. Now it's your turn. Let's try number 2. Solve 2x minus 5 less than 5x minus 22. Then graph the solution. Pause the video, come back when you're ready for answer. Okay, are you ready? What did you get? So the steps. If you subtract 2x on both sides, you get 5x minus 2x, so you get 3x on the right. And then if you add 22 on both sides, that's 0. And 22 minus 5 is 17. So 17 less than 3x would be your next step. And then if you divide both sides by 3, you get 17 over 3. And you don't have to flip the sign because it's a positive number. And so x is greater than 17 over 3, which is 5 and 2/3. So graph the solution. You're gonna put 5 here and 6 here. You can put 7 here. But 5 and 2/3 will be right here. Do you shade the circle? No, it's greater than. So you just go to the right, and your circle needs to be an empty circle. Alright, example 3. Understand inequalities with infinitely many or no solutions. Sometimes you have special cases. Let's look at some special cases for inequalities. Part A. You're going to solve this inequality, and you get rid of the x on the way. And you have 15 is greater than 9. Now, do you remember special cases from equations? Yeah, if the equation makes sense, then you have infinitely many solutions. If it doesn't make any sense, then you have no solution. It's the same for inequalities. Is 15 greater than 9 a true statement? It is true. So, this means that all x will work in this inequality. So no matter what x you have, it will work. It means the solutions are all real numbers or infinitely many solutions. Infinitely many solutions. Okay, part B is another case where you solve for the inequality and you get rid of the variable, And then you're left with an inequality that doesn't make sense. -5 is not less than -6. Or is it? No, it's not. Think carefully. It might be very tricky when you're dealing with negative numbers, but if it ever bothers you or confuses you, you can look at the number line. 0 is here. If -5 is here, is -6 on the left or the right of the number line? Yeah, -6 is further away from 0. So -6 is less than -5. So this is not true. -6 has to be less than -5. Since this results in a false statement, that means we have a no solution. Okay, so remember these special cases from inequalities. Let's look at try number 3. Solve each inequality. These are most likely going to be special cases. Please figure out if they are infinitely many solutions or has no solution. See if you can solve it by yourself. Come back when you're ready for answers. Are you ready? All right. First, for part A, you're going to distribute the parentheses. -2 times 4x is -8x. -2 times -2 is +4. Less than -8x plus 4. The next step, you're going to add 8x on both sides, and you are gonna see +4 less than 4. Is that true? No. 4 is equal to 4. If you had less than equal to, then it might be true. So, in this case, it has no solution. Okay, part B. Your next step is to distribute the right part. -3 times 2x is -6x. -3 times 1 is -3. And then you're going to add 6x on both sides to get -5 is less than -3. Is -5 less than -3? Yes. Yes, it is. It is a true statement. So the answer is all real numbers or infinitely many solutions. Okay, now you're all set with inequalities. Let's look at our last example, example 4, for an application. Use inequalities to solve problems. Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A or from florist B? If you look at the picture, florist A has a cost of $4.75 per blue rose plus $40 delivery charge. Florist B will give you $5.15 per red rose plus $25 delivery charge. You're going to write an inequality. How do you write an inequality? First, you want to figure out if it's less expensive to order from florist A. So you want florist A to be less than florist B. So first, figure out the expression that represents the total cost for florist A. The cost of X roses at florist A, because you don't know how many roses you'll have, 4.75x plus 40 represents the final cost. Should be less than the cost of X roses at florist B is represented by 5.15 times X per red rose plus 25 delivery cost. You're going to set up the inequality to find the number of roses it'll take for florist A to be less expensive. So if you solve for X, you get 37.5 less than X, or X greater than 37.5. What does this mean? It means when you buy more roses, when you buy more than 37.5 roses, roses are counted by whole numbers. So you're saying, so you can see that if you buy 38 or more roses, then this inequality is true. If you buy 38 or more roses, then florist A would be cheaper. But in the other way, if you buy 37 or less roses, then it means that florist B would be cheaper. So you can conclude that if Derek plans to buy 38 or more roses, florist A is less expensive. If he plans to buy 37 or fewer roses, then florist B is less expensive. So using that information, let's solve try number 4. If florist B increases the cost per rose to 5.20 instead of 5.15, for what number of roses is it less expensive to order from florist A and then from florist B? So set up an inequality and solve for it and interpret that meaning. So if you can solve it by yourself, come back when you're ready for answers. Okay, so what is your inequality that should have been set up? So your new expression for florist A is 4.75. Wait, florist A stays the same. 4.75x plus 40 is florist A. And then you want to know if it's less expensive to order from florist A. So that florist A is less than the new expression 5.20x plus 25 for the florist B. Okay, so then you're going to solve for this inequality. So 15 is less than 0.45x. You can simplify as 15 divided by 0.45 less than x. And so 1500 over 45 is less than x. And you can simplify to 100 divided by 3 less than x. And so x is greater than 33 1/3. Which means, in order for florist A to be less expensive, you need to buy more than 33 1/3 roses. So that means 34 or more roses would make florist A be less expensive. And that means if you buy 33 or less roses, then florist B would be less expensive. So let's wrap up and write that down. It is less expensive at florist A if 34 more roses are purchased. It is less expensive at florist B if 33 or fewer roses are purchased. And that is our answer. Okay, let's wrap up our lesson. Solving inequalities in one variable. In order to solve inequalities, use the properties of inequalities, which is very similar to equations, except you need to be careful with the negative numbers. If you multiply or divide by the negative number, you need to switch the sign. Alright, that was it for lesson 5, solving inequalities in one variable. If you have any other questions, please feel free to ask Ms. Kang in class. Otherwise, we'll continue with the next lesson, lesson 6, compound inequalities, in the next video. Thanks for watching. Bye!